For their, yep. They're subject based. So yes, last Friday I wasn't here. You guys had a sub. The reason was I was being trained. I had my professional development training, so it was a Zoom call, which I'm sick of those. But it was a AP Physics like consultant, like basically a professional teacher grader. She was from, I think, North Dakota, but she led a training seminar. It was all day, like 8 to 4, and it walked us through how to grade the FRQ questions on AP tests. Originally, the plan was you guys would have taken this mock exam. You would have taken a full practice exam. I would have taken your guys' FRQ answers, and I would have taken them to my training. And as they're going through, as they're going through, they would say, okay, the first FRQ question on the student's test was this question. Here's the grading rubric. Does anybody have questions? And they would walk you through specifically, why does this get a point? What about this example? Does this one get the points or not? And they walked us through how to actually evaluate and grade those FRQs, which they're tricky, right? Some of them are worded really difficult. Some of the rubrics were very specific on what a student needed to show in their answer in order to get credit. So we walked through all 5 of the FRQ questions that are going to be on your mock exam. And normally I would be able to return them like, hey guys, I graded your test. Here is your grade for the FRQ questions that you took on the practice test, the mock exam. Obviously I don't have that. You guys haven't taken the mock exam yet, right? So unfortunately, I won't be able to talk about specifically like, hey, FRQ number 1, this is what it looked like, and this was what the grading rubric is. I can't do that because you guys haven't taken the test yet, right? It would really take a lot of value away from you guys to see it first before you actually experience in a true AP simulation. That's the point of that mock exam, is a full-blown practice test of what it will be like to take the test. So I can't share specifics about those problems yet. When you guys take it, and again, when are you guys taking your guys' mock exam?
April 2nd.
Yep. Well, let me double check.
I bet I wrote it down.
I hope you guys wrote it down.
I believe I wrote it down.
Yes, Friday, April 2nd. Very good. Make sure you got that in your calendar. We're going to come back from spring break, and then that Friday, you'll have your mock exam. So I want you to be prepared as much as you can so that when you take that test, you get a real-life sample of how would I do. That is the whole point and the merit of doing a practice exam. Right? We're going to be studying, right? We'll prep, but it's going to be a snapshot of, hey, if I go take the AP test, what am I going to get on it? A 3? Awesome. I'm doing really well. I need to keep studying. I want to push for a 4, maybe even a 5. I got a 1. Oh my gosh. I got to pick up. I got to get my crap in order, right? I need to start studying every night. I need to come into Ish and ask Mr. H questions, right? You can look at the FRQs and be like, holy smokes, I completely bombed the Experimental Design FRQ. That's useful for you, right? You now know a specific type of problem that will likely be on the test that you can study and practice, right? It'll be really useful and a good kind of preview of what the actual AP test will be like. In this case, almost exactly a month from that practice test. So it'll be a month prior to your actual test. You get a preview. I'm going to try and grade them. Honestly, I'll probably just force myself to grade all of them over the weekend. That way, when we come back to class that next Monday, I'll have them done and graded already that I can give straight back to you and we can review from there. And I think that would be good, even though that'll suck for me, but that'll be good. So that's kind of what's coming up. Today, I don't have a lot planned. I wanted to talk a lot about the mock exam and share everything that I learned. I actually was able to confirm. I was like, hey, what can I tell my students that I'm learning in this training right now? She said, anything you want. So I was taking notes and getting down all this key info that I was learning, and I want to share that with you so that you guys kind of get that inside view of what do the FRQs look like, what are important things to be aware of, what are key strategies that are really important to the FRQs, what are insights to how it's graded. That's one thing that you'll get back when you take the mock exam. I'll have graded your FRQs, so you'll get feedback of what you got points for and what you didn't. As we are practicing FRQs, I want to do at least one a week, maybe even one a class period now that we don't have new content. Just take like 10, 15 minutes, do a practice FRQ. I want to start having you guys grade other students' FRQs. I think when you are forced to look at the grading rubric and actually grade someone's work, it really helps you understand what is expected on an FRQ question. You'll be able to see the rubric and says it gives 1 point for correct answer in part A. Like, okay, if I were taking this test, all I would need to do is get the right answer. Right? Part B is like they get 1 point for the correct equation and 1 point for the correct mathematical derivation. Right? So then you're experiencing, man, I would need both of those parts for this question. If I got both of those, I would get full points for part B. Right? It helps get that in your mind, and it also lets you evaluate other students' work. So you get to see, this is what a student did. Do they meet the expectations on the rubric? Yes, they get points. Wow, this student got all their points. That's on track for a 5 if they keep up that work for the rest of their AP test. Right? Or you grade it like, man, they only missed 1 point. They're doing really well. Or maybe they answered all the questions wrong. Well, you get to see, what did they get wrong? They had the wrong answer. They had incorrect mathematics, like the derivation is wrong. They forgot to explain the steps of their design experiment, whatever it is. It will be really helpful to have you get your mind prepped for FRQs because they're really unique. And the grading is very particular, right? That they have to make it objective so that it's not up to me like Mr. H, I think they know what they're doing. They get full points. I don't care what I think. You shouldn't get a grade on what I think. You should get a grade on, did you use proper physics? Did you do your math correctly? Did you follow logical orders? And did you get the actual answer that they're looking for?
That's why I didn't like taking mine on Friday. I'm like, I kind of think I got that point, but by the situations, I kind of don't think I did.
Yes, and that's what I want you to see is certain questions, they're looking for something specific. One of the biggest things I'm going to show you now is she prepared a list of what she called task verbs, or like the action verbs of FRQs. It's a list of these words you're going to see in the FRQs, and whatever word is chosen will really impact what you're supposed to do for that question. Let me find, so I have my training folder up. I want to pull up the just kind of random notes that I was taking. Where's her action verbs? Verbs here. You know what? Oh yeah. There it is. She provided this. So I want to walk through and show you my notes and these task verbs. So these are my notes. Some of them are useful to you, some of them were just for me, like units 8 through 10. Those units are not a part of this class anymore. They're not going to be on the test. That's why we stopped doing more units at unit 7. Your test will be over units 1 through 7. You don't need to worry about 8, 9, 10. they mentioned there aren't any current plans to bring those back into Physics 1. So if you got buddies that are like, hey, how's AP Physics 1, right? You can tell them most likely you won't have to do 8, 9, and 10. That's more for me in the future. This is a cool app I mentioned. This is another thing that I don't know if you guys are aware of or if AP Classroom gives you like notifications. But starting on April 19th, YouTube, AP's, like, I don't know what channel it is, but their channel on YouTube will start having review sessions. They'll probably be live, and then I would hope that they would record it so that if you missed it, you can watch it later.
I think each test has their own channel, I think.
Or maybe it's their own playlist.
Their own playlist. I just remember like when I clicked on it has like its own. It's not just super general.
It might be, yeah. I can't. I don't remember off the top of my head, but anyway, they should be making notifications in Classroom as it gets closer. But I want you all to be aware that, again, starting April 19th, they're going to start making review sessions for the AP test. So that would be a really good resource for you to keep in mind, that I would strongly encourage you to at least check out the first couple, right? See how they go. You might find these aren't really helpful. I don't really gain anything. That's your choice. You don't have to keep watching them. You might decide, wow, these are really helpful. I definitely want to watch them all. And there's going to be 10 days worth. So it's going to go basically through the end of April, right? It also, I don't know how they'll structure them, but I imagine they'll go through all the topics. That might be a really good resource to do additional review, right? They might start with Unit 1, and maybe we reviewed Unit 1 a little bit, but reviewing it another time is really helpful. If they're recorded, you could also watch them at like 1.5 speed. As long as you can understand what they're saying, you can get through the material quicker. However you want to use them, I want you to be aware that those are coming from AP. They're going to be likely great resources since it's coming from AP, and this is an AP test. All right? Guys, are you with me, or am I wasting my time? I think this is super helpful. I want you to make sure you're actually getting something from this time. One of the things I captured from her quick presentation was the weighting topics. So if you notice, these are going to be, I think they're slightly different than the original plan. Some of them might be the same, but some of them are different. Actually, they all seem sort of the same. Interesting. So the exam weightings are the same as they were originally. What I think that means is that all these percentages, they're going to use the upper end. So all that to say, the weightings on the test are going to be what we've had from day one, right? You'll notice, Unit 4, really important unit. Potentially a quarter of the entire test will be about energy, right? We need to get strategic. We want to make sure we know on energy. We're going to make sure that we got that ironed out because there's a lot of benefit to knowing energy. There's a lot of points that are going to be able to be made from that unit. Dynamics and kinematics, those add up to about 1/3 the test, right? A little bit more, actually. Momentum is another pretty big one, potentially like 16%. Torque, rotation, motion. Notice, circular motion, gravitation, and then simple harmonic motion are very small, right? We're not going to spend a tremendous amount of time reviewing those, given that it's such a small chunk of the class. This is Mr. Armstrong. Awesome. I'll send them down right now. Thank you. Josh, I want you down in the band room for a picture, like solo ensemble picture, I'm pretty sure. Yeah, so they want you to head down as soon as you can. So I'd hustle straight there. I think they're like taking a picture now or something or other. Okay.
I wanted to make this as fair as possible.
Yes, so guys, this was the point. I didn't even read the own slide. If you add up the maximum possible percentage for each category, that's 100%. So you can pretty much expect all of the maximum possible percentages is going to be what's on the AP test, at least very close.
Yeah, I was curious. So I added up the minimums, and it only adds up to like 64%.
Really?
So it's going to be hard.
Yeah, and that would be assumed, yeah, all the minimums wouldn't work. But in this case, because we got rid of those units, that means those maximums or at least will be really close. So energy is going to be a big unit. It will likely be a quarter of the whole test. So I wanted to pass that along. The AP review sessions, I double-checked. This is another one that we'll talk about, the FRQs. The only time that students actually you guys will need to write full sentences for FRQ questions is the paragraph length response questions, which will be explicitly stated. Right? This is something that you can be strategic about. If it's asking me to write a paragraph length response, guess what you need to do? You need to write a paragraph in English, not in math. You need to use actual sentences. However, that type of question is the only time you need to use full sentences. Other ones, if it says like, explain your experimental procedure that you would use for this type of situation. You can give me bullets, right? Like measure mass on scale. Use meter stick to measure length of track. Calculate force using F equals ma. Just do bullet points. You don't need to give me paragraphs or complete sentences. So I want you to understand that so that you can save yourself time, right? There's only one type of question where you're going to actually have to write full English sentence to explain yourself, and those are the paragraph length response questions. They will be stated. It will literally ask you, write a paragraph length response to blank question. When you see that, you're like, okay, now I need to write my paragraph. Any other time for FRQs, bullet points, equations, phrases, whatever it is, they all count as long as you're demonstrating what you're saying, what equation you're using, a human being could understand, right? That's all you need. I didn't know that, and I wanted to make sure you guys are aware of that because this will save you potentially a lot of time on a question where you don't got to write a paragraph. So why are you? Now I want to focus on the task verbs. These are a list of all of the different verbs that you will probably see on the FRQ questions. And it gives you an explanation of like what you're supposed to do with that task verb. Was it just a photo op?
That's it.
Nice.
Ask for a whole 2 seconds.
Josh, just so you are aware, the big point I just made was this right here. She made sure to emphasize the only time that you as a student need to actually write full sentences in order to get credit will be the paragraph length response. Those questions, the question will literally ask you, write a paragraph length response addressing this question.
Yeah, and then when it gives like letters with I or I
Yeah.
to I, you just throw words down.
Or if it says, like, explain the process to do this lab, you can give me bullet points.
Yeah.
Take a mass measurement with a scale.
Now,
Measure this with a meter in it.
Did you tell
Calculate
them
it.
to actually label each question? Like the actual mark each question?
Like A, B, C?
Yeah.
Yes, the question should... I don't actually know what it will look like, but the practice test that they gave, it was like the main question, then part A, and there's a big chunk for you to do your work. So it would already be organized for you.
Okay, well,
But if
on
you're...
some of the questions, like on the first response, they'll have like I and then I.
Yep.
I.
Yes.
And what I was told is don't write that down. like don't actually write I or I or I down, because if this way, if you like mess up and you mislabel something, because if you label it I, if you accidentally answer I, then you don't get the points.
True.
Now, if you or if you answer like the question wrong, but it could have been correct for another question.
Yes.
So I've been told don't actually.
Yeah, that makes sense. So part A, if it has I and I, just put all your work there. I guess there wouldn't be a need because all of that work is part A, so just leave it there. The other thing that the rubrics are actually helpful to you guys, they try really hard not to double ding you in grading. What I mean by that is if you get part I wrong, but you do the process for part I correctly, you would still get points for I. Because you did that process right, you get points. They don't give you a point for right process, right answer, because then you'd miss the points for part I, and then you'd also miss part I because you got I wrong. They do a very good job of not double dinging. So in those situations, they're going to give you as many points as they can. Right? If you did the second part correctly, you're just using the wrong number because you messed up part I. You're only going to lose those points once, and then you'll get credit for the second part for doing the process right. So they do take that into account. Task verbs. I'm going to focus on the 3 that she emphasized specifically. She said these 3 questions are very important. You'll almost guaranteed see them. She wrote down the task verbs. So the question would be like, calculate the momentum that occurs as a result of this collision. Calculate is the task that you need to do. On a free response question, calculate means perform mathematical steps to arrive at the final answer, including any algebra expressions, so equations, properly substituted numbers. If you're plugging in 9.8 for G, that needs to be in your answer or calculations, and correct labeling of units and significant figures. I don't think they're going to be that picky, but units are important. Sometimes they'll phrase that as what is. What is the momentum that occurs from this collision? Those calculate problems, that's what it's looking for. It's looking for step-by-step math. It's looking for what equation did you use. Don't pull a number out of your butt and write it on the page. In this case, you won't get the point.
That was my full.
Or you might get the point for the right answer, but you don't get a point for the calculate aspect, which is showing your work and calculations.
What if you show the wrong work but still get the right answer?
In that case,
you do the wrong process but still get the right answer.
You would most likely get a point for the right answer, but you would not get a point because the point for the right math in this case, like they have examples in the rubric. You need to start with conservation of momentum. You need to plug in and solve, right? So they're going to look for, and then if none of the example solutions are what you did, then that's when the physics teacher that's grading is going to step in and be like, does their physics make any sense? Actually, yeah, it does. Wow, they solved this in a really creative way. They get points. Or if they're not sure, they would pass it up to like the table head, like the main grader, and they ask them, I want your input. Would they get the points or not? Right? Those are the people that have been doing this for like 10 plus years. They weigh in and say, yeah, actually, yes, their physics works, it's correct, and it gets them to the right answer. So even though they didn't do it by the rubrics example, they did do it correctly. Derive. Do you guys know in general what it means when it's asking you to derive something? Not quite. Not take the derivative. It means to come up with.
That's why I said to bring out.
Yeah. You're going to use basic equations and combine them and show how they come to the, say, final answer or final equation. It's mathematical steps that you're adding together, simplifying, canceling things to arrive at the final answer or the final equation. So derive, you don't even need words. You can list starting equation right? Substitution, cancellation, plug in this number, and then this is the final equation, and that's my answer. Full points. You've shown the right steps, and if you've got the right answer, then you're good. That's what that derive means. And then determine. Determine is make a decision or arrive at a conclusion after reasoning, observation, or math routines. They're calculations. There was one word that really surprised me. I'm pretty sure it was determine. Because one of the questions on the I probably shouldn't.
Spoilers. You really think we're gonna remember this by the time we get to?
No, I can share this. One of the questions, one of the parts of the FRQ asked you to determine. When I was grading it,
Yep, you spilled the beans.
when I was grading it, I was like, wait a minute. So the only thing that matters is the final answer they circle? And they said yes. If they have the right answer written, full points, no matter where they got it from. They could have picked a random number. If you wrote it down and it's the right answer for the determine, you get the point. Right? So I was looking at it and I was like, man, their math is terrible, but somehow they got the right answer, but I don't think they knew what was going on. And the grader's like, it doesn't matter because that question is only looking for the answer. Whatever answer you pick, you have to determine solely on that answer. So, right? So it's really weird. If you really do stuff in your head, derive, you have to put your steps down. If you do it all in your head, you'll get maybe a point for the answer, but you'll miss the point for the derivation that you were asked to do. On a determine question, go away in your head, right? It doesn't matter. Right? The only thing that you need to put would be the answer. And that was really surprising to me. Right? So if the answer was 0, I couldn't care how you came to that conclusion. If you put 0, you got the points.
See, 46 times 18,000.
Yeah, is 0. I wouldn't be able to say you're wrong. If you did the wrong math but wrote 0 and 0 is the answer for a determined question, I would have to give you the points. Even though your math is garbage.
Can you imagine being the grader and you see someone just like literally just draw random stuff like John's bullet bill fish and then put equals correct and then puts the correct answer in them?
I'm going to do the right equations, like off to the side somewhere, and then on the actual thing, you put random numbers.
I was going to say, if you want to be a smart aleck, put like complete garbage math, but then write the final answer that you know is right because you actually did the work otherwise. Risky move, but if I was grading that, I would get a kick out of that. True. That's another thing. You guys are going to be crunched to time, so don't...
I probably won't have the time. If anything, all I know is that like if I'm pushing for time and I have to guess on one, I'm going to guess on that. Just let me write some random number I come up with.
Yeah.
The alphabet is square, and that's why I did
So
12.
So right here, I want to make sure I walk through these. Compare. If the question asks you to compare two things, it's looking for a description or explanation of similarities or differences. Again, you wouldn't need full sentences. You could give me like a Venn diagram. As long as you're using like English phrases that have coherent meaning, you would get credit. Because as long as you've provided a description of similarities and or differences, you've compared whatever they're asking you for. Describe, provide relevant characteristics of a topic. Again, you don't need a paragraph. It doesn't ask you for it. You can do bullet points, you can do phrases, you can do a list, whatever you want, as long as you're describing. Because they're going to look for it. Did they provide relevant characteristics of blank? Evaluate, make rough numerical quantities. Right? Signs are important based on evidence that was given in the problem. When you make estimations, show steps in calculations is not required. You could estimate and give your final answer and write it down, and you would get credit. So, you know,
the final answer can be an estimate, and you can still correct it.
if it's asking you to evaluate, right, you can make rough calculate. Sometimes it'll be like, evaluate the approximate momentum if you had 3 times the mass. Now, it probably wouldn't ask that. But evaluations are roughly calculate. So you could round.
So if
You could say gravity is
9.6,
10, not 9.8.
Ooh, yeah.
That's a fine approximation, right?
okay.
And you don't need to show your calculations. It's just looking for a quantity that you found through yes, correct math and yes, correct physics. But again, you can be rounding, you can make simplifications, stuff like that. Explain, this is a big one. Providing information for a relationship, patterns, using evidence and reason to support your claim. Have you guys heard of that CER method? Claim, evidence, reasoning. They suggested that a lot of students that's helpful for them for, like, say, explain. They're going to make a claim. Like, it'll say, like, explain why the momentum is doubled. Your claim is the momentum is doubled, blah, blah, blah. Or just say the momentum's doubled. You then need to list what is your evidence, right? You can cite equations, data, whatever the question gives you. And then your reasoning is, okay, tell me why that actually supports your claim. And you can say, from the data, you find that the mass gets doubled. If you use the equation for momentum and double the mass, the overall value of momentum is doubled. Therefore, momentum is doubled when you double mass. That you've explained and rationalized it. And you could format it, claim, evidence, reason. That's a perfectly valid way to explain whatever it's asking you to do. Justify means you need to provide evidence to support a statement. Right? Often the question will tell you, or sometimes it'll tell you what you're supposed to support. Right? Justify why the momentum is doubled when you double the mass. Right? You need to tell me, okay, what evidence actually supports that claim, and then why. That's what it's looking for when it says justify. John? Yes, I think I can provide this to you.
Well, I mean, if not, we're just going to go to the video.
True. Yeah, I've already kind of dug myself a hole.
Well,
I don't think this is proprietary, so I'm pretty sure I'd be A-okay. No, they told me I can share all of this info to you guys. This isn't hidden secrets that you can't know.
So then it wouldn't matter. Because this is
I know.
a process. It's not like
I know, I'm just trying to be careful and make sure I don't make any assumptions.
it's okay, you
But
still
yes,
have to
John, I will add this. I'll make a post for today and attach the recording, but I'll also attach to this document. That way you guys will each have a copy, so in your own time you can kind of go through this. Good question. Label. Provide labels indicating the unit, the scale, or the parts of a diagram, model, whatever. Right? Self-explanatory. Plotting. You're going to have to make a graph, right? Plot a couple points, maybe draw a line. Sketching, drawing. You might have to make a diagram, a model, or something that shows relationships. Labels may or may not be required. That'll probably be given in the question. Here's one. State, indicate, or circle. Indicate information about a set topic without elaboration or explanation. So you literally just have to say an answer.
You.
And then verify is basically tell whether something's true or not, if it agrees or not. Also use data to confirm or justify your hypothesis. All right. So again, this is just, I wanted to take a little bit of time and walk through like what the heck could we expect from FRQ questions. Almost every single FRQ question is going to be using one of these verbs that's looking for something specific. You need to keep that in mind, right? you need to make sure you're doing what it asks you to do. If it's asking you to sketch or draw and you start using words and you're just describing something, that's not at all what it's asking you for. So you want to be able to stay focused on what it's asking you to accomplish. Let me go back to my notes. Again, best practice, I'm going to start having you guys grade your classmates' FRQs. 1, be able to give them feedback, and you'll get feedback. But 2, you acting as the grader will be really good practice and exposure to what's going to be expected of you on FRQs. You'll get to see the rubrics and look at, like, oh, wow, they wanted me to do this equation to start with, or I needed to give an answer and a reason. Oh, I only gave an answer. Whoops. I maybe forgot to look at my task verb. The task verbs are super important. You need to make sure you're reading carefully. Right? They might have a big old question at the very end. It says, state the momentum. Right there, you're like, I don't care how I get there. I literally just need to write an answer because it's only asking me to state. Other times, in general, reading the question carefully, you guys have seen me mess some things up because I misread the question. Right? That's just common strategy. Task verbs, I showed you the list. She really recommended we practice the paragraph FRQ questions, the paragraph length responses, and the experimental design questions. Because she said in her experience, a lot of students, they mess up the experimental design questions, which would kind of like ask you, how would you measure this quantity given these supplies? And you'd have to say, like, I would use these supplies to measure these variables. Here's the order that I would do it. When I calculate, I would use this equation, calculate this number, and there's my final answer, whatever. My tips for experimental design, you should start by thinking about how they would actually analyze data. Like, how are you going to get data? Right? What do you need to find? Like, well, it's asking me to compare the momentum. I need to figure out the mass and the velocity. Well, how do I measure mass and velocity? Okay, mass, I could use a scale. Velocity, I could use a photo gate or a velocity sensor. That's going to carry back to starting the experiment. It's going to ask you, what supplies are you using? What are you going to measure with those supplies? What's your procedure? Right? You're going to have to tell them, I do this first, then I do this, then I calculate this, then I compare this. They need to be specific. You need to match the equipment with the measurement you're taking. She was saying, like, for example, some students would say you would measure energy with an energy meter. First of all, what the heck is an energy meter?
You know,
2, where did you get that technology?
It's the meter that measures energy.
And 3, like, okay, what type of energy? Energy is a super vague statement in physics.
All of them.
So you would get no points for that. If you wanted to measure, here's one. Would measuring potential energy be a good thing to measure? Emphasis on measure.
No.
No. Why?
Anything can have a
Yeah, we don't have something that tells us potential energy.
plus.
You can calculate it. You can calculate it easy. What is the equation for gravitational potential energy? You guys remember it?
It's U sub G.
Yes, potential energy of gravity, good.
I know it's MGH.
Bingo, there you go, Brody. MGH.
Brody.
It's basically force of gravity times the height that it's lifted up. That tells you how much energy it has. That's an equation.
I'm gonna remember that.
That's not something you measure. What would you measure? No. That the potential energy example. What are you actually going to get something out and measure to find potential energy? Mass and height.
And what's
G is gravity, which is a known constant. You don't need to measure it.
unless they specify otherwise.
Do you see the difference in those two situations? Measuring gravity or potential energy with an energy meter? No points. That doesn't make any sense. Nobody could do that. You would measure mass with a scale, right? What would you measure height with? Meter stick, ruler, tape measure, whatever it is. I can measure those things, and then in your procedure, you would tell me measure the mass, measure the height with a meter stick. Then calculate with this equation. I know it will sound nitpicky, but think about it. If you're doing a lab, in the instructions, if I gave you a lab and said, hey guys, you need to go measure potential energy with the energy meter, could you actually do that?
It is not moving.
Yeah, you can't do that. So that's terrible, terrible instructions for a lab. That's important because they're not going to give you points for terrible instruction, right? It sounds nitpicky, but I'll do this right now. Oh, wait. I want to finish this up for the experimental design. Do a bulleted list, or a numbered list is even better, right? Don't give me a paragraph of step-by-step instructions for a lab procedure. Make it easy on the grader to give you full points. Give me a numbered list. Literally, step 1, take a measurement of the mass of object with scale. Step 2, use ruler to measure height of track. Step 3, calculate potential energy with the equation U equals mgh. Literally tell me step by step what you would need to do for that experimental design. I can almost guarantee you there will be a question like that says, hey, we have this problem, we want to investigate or measure this. Tell me what kind of experiment we could do to measure it. You'd have to tell me the step-by-steps to measure it, calculate it, and actually answer the question. On that topic, I want to show you a really funny video. Has anybody seen this? The exact instructions challenge? This is really funny, and it's directly related to what I was just talking about of step-by-step procedures. Darn it. I'm guessing that's a pun. Josh, darn it. I don't know, but...
Otherwise, his parents have 1, 6, and 2.
Josh, will you turn that Bluetooth speaker on?
Josh, darn it.
I'm Josh.
Just that button. Yeah, there you go. Alright, and then I should be able to connect to it here.
I just hold it down. Sometimes you have to change the setting.
This is really funny. Why won't it let me?
John was having the same issue.
You're not still connected, are you?
I don't think so.
No, because it wouldn't even show up to it.
Is that on or not?
It was on.
Can you boot it up again? I can't tell.
Oh, now it says bye.
Is that saying Bluetooth?
Yeah, it says Bluetooth. Well, it says Bluetooth.
Oh, there. I think it couldn't. Yeah, good deal. I want to blast you out. There we go. All right, so again, I want you to, we don't have to watch the whole thing, but I want you to at least watch a little bit. This is something that, it's a bit of a parody, but it's really important to show you what they're going to look for on, say, an experimental design. You need to give step-by-step instructions that someone could actually follow your instructions and do the right thing. This is an example of the opposite.
He already ruined it on purpose. He knows how to make one.
This is so funny.
What's up, Peter?
You know what? I'm hungry. I could really go for a peanut butter and jelly sandwich. You guys think you can write down some instructions and teach me how to make a peanut butter and jelly sandwich?
Yeah.
Then do it.
I knew we were gonna do this. I heard Dad talking to Mom.
Don't choke yourself on the Sometimes they do what you tell them.
That's like
Dad, I'm done.
Step 1. Get 2 pieces of bread out.
No!
Okay, the school Wi-Fi.
Done.
School Wi-Fi.
Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
Well, it doesn't say to do that. Put the breads together on top of each other. Take a big bite.
Oh, no. Sorry, I had to make it extremely specific.
Oh, good. I'm starving. Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop a bit of peanut butter out of
That means like a lot.
A bit means a lot.
In my world.
Spread your scoop of peanut butter onto 1 of your pieces of bread.
I don't really approve of those graphics.
There we go.
Doing better than before, though.
Open the jelly jar. Squeeze it onto the other piece of bread.
No.
Done. Closer. Get 2 pieces of bread. Get some peanut butter. Take the peanut butter knife. Open the peanut butter. Put the knife in the PB. Get some jelly. Open the jelly.
No.
Squirt the jelly onto the bread. Take the butter knife with the peanut butter on it. Wipe it all over the piece of bread. Take the butter knife. Rub the jelly all over the piece of bread.
Oh, he's doing better. Oh.
That's all over. Put the 2 pieces on top of each other.
This is how I meant.
Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar.
Funny.
With the knife, scoop some of the peanut butter out of the inside of the jar. Spread your scoop of peanut butter onto 1 of your pieces of bread with the knife.
No.
Squeeze some jelly onto the other piece of bread. Spread the jelly on the bread with the butter knife. Put your 2 pieces of bread, peanut butter and jelly sides together. Done.
Alright, so we don't have to keep watching this, but I think that makes the point. You won't have to be that specific. But the gist of it is you need, if you're doing an experimental design question, and you're writing down your instructions, like step 1, step 2, step 3, you need to pause and actually reread your instructions. Like, if I do this, then this, then this. 1, does it make sense? 2, am I forgetting something? Or 3, am I being too general? Right? On the AP test, it's not going to be this picky, right? But the idea is you need to give a complete list of what is needed. It needs to be in order, and you need to be specific with what you're saying. Like, measure the mass of the object using a mass scale, right? I've told you what to do and what to use to do that. right? Someone could follow that step and actually do what you're talking about. That's something that you really want to pause and think about when you're doing experimental design questions. The CER I've talked about. Claim is what you're trying to state. Sometimes the question already tells you that. You just have to give the evidence for it. Evidence is, actually that's what I just said, is what information, what data, what do you know that supports it? And the reasoning is, okay, connect the dots. How does this support this? That's a common way for students to kind of structure their answer. The paragraph length responses. This is a good summary of how the points are broken up. You'll have a small question that may or may not lead to the paragraph, right? There'll be at least 5 points for a paragraph response in total. 1 point for a paragraph format. You can use bullets if you're using complete sentences. So even in a paragraph, they give you the exception of, hey, it doesn't actually need to be a formatted paragraph as long as you're using logical, ordered, full English sentences. And then all the concepts need to be in there as well. Right? You need to connect to this equation. Say, using conservation of energy, we know that the energy doesn't change. Right? State what concepts or laws you're talking about as you explain something. And that's kind of in a nutshell, what I had written down. I think that's all I can share for now, because the other stuff that I wanted to share was specifics about each FRQ individually. Obviously, I'm not going to do that because you haven't seen them. I want you to...
We'll forget it by the second.
I'm still not going to. But again, when you take that mock exam, I'm going to grade them, and I'll give them back. And you'll literally see my grading of you got a point for the answer, but you didn't have the correct justification. Or, whoa, you didn't use complete sentences for the paragraph question. You lost points. Right? I'm going to give you clear feedback so you can kind of learn what you're getting and what you're forgetting. Another, talking about, I guess, science in general, experimental design question. I want to show you a really cool, funny commercial that has actually really strong ties to what science is and what we're trying to do when we do experiments and try to get data. Like, what is our goal? So I want to play this. It's called My Dad's a Space Alien.
I have evidence that proves my dad's a space alien. He speaks a weird language. He drinks green stuff. He says he's from Albuquerque. I'm not buying it. I mean, just look at him. And one more thing. He has a spaceship. The evidence doesn't lie. My dad is an alien.
A highly advanced research made the current drives
That's a Google commercial, but that works too.
A Google one? What'd you say, Maggie? Why, of course.
Because those are just so bougie.
Yeah, and Audi's really big. They love their tech. So, of course, the spaceship, yeah, it's going to be an Audi.
Yeah.
She made a really bold claim. She said the evidence doesn't lie. Which is to say, the evidence that she presented absolutely proves that her dad is an alien.
Yep.
Do we believe her scientific statement?
Yeah, you did.
She gave evidence. I said it out here.
I know you guys are mocking
Yeah.
because the answer is no. We do not believe her claim. However, is her evidence wrong?
No.
What evidence did she give?
He speaks a weird language.
Speaks a weird language, him gargling. They had video. That was evidence.
He's from Albuquerque.
Albuquerque, right?
Green stuff.
You can confirm that.
I'm not buying that either. Maybe Mr. Heinlein thing. I've never heard of the name Heinlein until you showed up. So you're not an alien. You come from a state that no one's ever heard of.
Iowa is real. It's just a fictitious communist state.
It's real, and he said it's fictitious.
Okay, bring it back, guys. Again, she was saying speaks weird language.
Drinks green stuff.
drinks green stuff, look at his outfit from Albuquerque, and drives a spaceship. The spaceship one, that one's obviously not a true piece of evidence. It isn't a ship that travels into outer space. But all of her other evidence is valid.
Except the Albuquerque one. She said she just didn't buy it.
Yeah, that's also, you would have to fact check that. If that were true, then it's a piece of evidence, right? It's just a statement. If it's not true, then that's bad evidence. And you're right, we would have to verify it.
Like outer space, so technically isn't this whole room full of space?
That's a good question, right?
So,
you could argue what is the definition of a spaceship? Maybe it's a ship that moves through space.
Exactly.
Well, we exist in a 3D space. However, my point is, she had some legit pieces of evidence. And then she said, all that evidence doesn't lie. My dad is an alien. A space alien. Right? That is technically okay science. You gather evidence and you make a claim based on the evidence. Science isn't what?
Chill stuff.
Oh yeah, that's when I really like chill step. Thanks for pointing that out, Maggie.
You're right. Third of the way through it. That's why I was so confused.
Yeah, so I really like chill step because it doesn't have lyrics. So I can actually study to it, and so when I grade, sometimes I turn that on. But anyway, science only cares about what is your evidence, what's your reasoning, and what claim do you make. You could say some crazy stuff in science, but in order for it to be accepted as a proper scientific argument, your evidence has to be valid, like actual empirical, measurable evidence.
Canada doesn't exist.
And you have to have reasoning. There has to be logic to why does this evidence agree with what you're trying to say. So this is a situation, she made a scientific argument. But was it a good scientific argument?
Not really.
Not really. Right? Maggie pointed out saying that he was from Albuquerque as a piece of evidence. We don't know if that's true or not. So you can't say that's evidence. You would have to confirm it.
Well, but she
Huh?
said
It's
that
in
he
your
said
birth
he's from Albuquerque.
Right. Huh?
She said that he said he was from Albuquerque.
Right, but her evidence was he's lying. That's not evidence. If you proved he was lying, that's a piece of evidence. Right? Drink green stuff, that was a fact.
But
Video
he
evidence of it.
Maybe he never provided proof that he was actually from Albuquerque.
He said he's from Albuquerque.
I know. My point is, your evidence and your reasoning matter when you make a claim.
Like, you saying you're from Iowa, but you have yet to be able to show us where it is on the map.
Yeah, but why was he lying?
What? Again, it's a Minecraft chunk error. That's what Iowa is.
I could show you on a map, but that actually doesn't even prove that I'm from Iowa. That just shows you where it exists on the map.
But if it doesn't exist, then we know you're not from there.
Oh my gosh. We are digressing greatly. My point is I'm trying to talk a little bit about that experimental design type question. I want, as we go through and review, I want us to go back and try some of the labs that I either didn't have time for or didn't want to or didn't think I could set up so that, one, we could practice. Sorry. One of the things that I really want to practice with you guys is I want to give you a lab where I just say, here's the equipment you can use. I want you to try and analyze or evaluate the momentum of this object. Go. I'm not going to tell you what to do. I'm not going to tell you what you're supposed to do. You are going to have to figure out what information do I need? What do I need to calculate? You're going to have to write me a procedure of, hey, Mr. H, we did this, this, and this. Then I'm going to have you actually do it, collect some data, do some calculations, see what your answer is, and then make a statement. The momentum of this object was blank. Here's how we found it. I want you to be able to practice the full experimental process. That's what real science is. Humans have questions about how the natural world works. Nobody gives them a lab report or lab instruction that says, here's how you test if gravity exists or not. No, we came up with how would we do that? Well, we could do this, we know this, we could measure these, we could calculate, we could see if it works. They did it, gave their results, and made a conclusion. Right? I want you to practice that because I can almost guarantee one of the big FRQ questions will be an experimental design question. Either it will ask you to critique an experiment that a fake student did, or it'll ask you to make your own. So you're going to need to know the physics, know what you need to calculate, know what equipment you're going to use to measure what are the steps you're going to do, what answer are you going to get, how do you know that, talking about error, things like that. So I want us to have a couple labs I'll throw up as review, but also real life practice of how do I make my own experimental design. I want us to practice that before we get to the test. I don't think I have anything else to talk about. Oh, that was where I found that video. Okay, so help me out. Is there any other questions that you want to know about the FRQ, the AP test, anything that I can talk about while it's kind of fresh on my mind from the training? I almost guarantee there should be 5 free response questions. Sometimes it might be 5 or 6, but the total points of all those I think should be like 50, if I'm not mistaken. Because I think is your multiple choice 50? I don't know if it's actually identified. Another cool thing that I learned is from AP Direct, like AP's website, they actually have the last 5 years of AP tests where they've posted the questions, posted the statistics, the results of the test. They've posted the FRQ grading rubrics, which is literally what the graders would use to grade the FRQs. They've posted 5 real student responses to the FRQ questions. And I think there was like one other piece of info they posted.
Just imagine you're checking over one of those tests. Your answer was their example for like a 0.
That would be frustrating, but also useful for other people, not AP Classroom. So I don't want you guys to go out and get these because I want to use some of these in class, right? I don't care too much, but I want you to see AP has practice exams. You could take 5 full-blown practice exams if you wanted to.
But who?
It's all there, right? AP Physics 1. Where are the...
So I'm understanding for this class, but who would willingly write a DBQ, like on the free time?
A what?
A DBQ.
What's that?
These are not.
Oh, gotcha.
So, yeah, I'm talking about for like other AP classes, like same for this class, and then just like multiple choice and FRQs, but. I don't know, volunteer yourself for a DBQ.
There was no volunteer myself for any sport.
Yeah.
Right here, do you see this? 2019 FRQ. Here's the questions. Here's the rubric. Here's the statistics. Here's 5 sample student responses. And here's the scoring distribution.
Do they have one for 2020?
What do you think? And then if you go here, look, there's 2018, 2017, 2016, and 2015. So there's some awesome practice for FRQs. And in class,
Of course, 2001.
what will be really helpful for you guys is I will literally pick one student response, or maybe I'll give a couple different. And in class, our activity would be you guys grade this student's FRQ. Because it's going to give you insight of what are they looking for? What understanding did they have to show? Right? What grade did they actually get? Right? That's going to be huge practice for the FRQ. And we have 20 potential examples. Actually, more than that. There's multiple student responses, right? There's student A, there's student B. Oh, these don't load well. So actually, we have 5 years of testing, 5 questions per year, and 3 students per question. What's 25 times 3? 75? We have 75 practice FRQs that you could practice grade or practice solve yourself. Right? Some days, like, I'll give you, like, hey, got another FRQ. Let's try to knock it out. Also, the one straight from AP. Let me confirm. Right here. The directions tell you, okay, hour and a half for the FRQ section of the test. There's 5 total questions. Questions 1, 4, and 5 would require approximately 13 minutes apiece. The AP test will help you right away. Oh, crap. How much time should I spend on this question? I don't know. They already tell you it should be about 13 minutes. 2 and 3, each of them should take about 25 minutes. So that's going to be another key strategy when you're taking FRQs. Right? Read those instructions and write down, like, okay, question 1 should be about 13 minutes. Okay. Right? Try to time yourself. Like, okay, I'm starting right at 9 o'clock. At 9:15, I'm going to check myself and make sure I'm done and move on. Right? Because time will not be on your side when you take these. So again, I'll use these. These will be tremendous resources for us in class to be practicing. We'll do practice FRQs. I'll have you practice grading them, right? And then we'll also be reviewing content. Before I shut up for the day and let you just kind of hang out a bit, do you guys have any input for me of how you want us to be reviewing or how I can help you review in the most effective way possible? I'm going to do practice FRQs. I'm going to do practice grading FRQs. And I'm going to pick random topics so we can kind of cover all topics. That'll be review, but you can kind of expect that consistently so that we're consistently doing FRQ practice for a small chunk of every class. Outside of that, I'm going to have some labs every once in a while that I'm going to try and get set up and have you guys practice, do some more hands-on stuff that we didn't have time for. The rest of the time, what do you want me to be doing for you guys?
Maybe we just work like unit 1 and unit 7 again, like start from the beginning.
So take like a couple days and review all of unit 1 stuff? Okay. Okay. Okay, so do kind of like have me basically reteach Unit 1, brush back up on the material? Okay. Right, I can definitely do that, and we can go in order if you want. Like, okay, let's start with Unit 1. Let's take, this week, we're reviewing Unit 1. This week we're doing 2.
Some weeks we'll have 3 classes.
Right.
So you're gonna like.
I'm approximating. That's not a hard and fast commitment I'm making. Okay. I'm just approximating, like, we'll take this next couple classes, however long we need, we'll review Unit 1. Maybe it's only 1. Maybe we fly through and like, yeah, Mr. H, we got this. Right?
Like almost like 1 a day on some easier ones.
Right. And if I'm reviewing, I want to take as much time as we need, but no more. I don't want to waste all of our time. I want us to make a lot of progress, cover a lot of stuff. Okay, so I can go unit by unit, review the concepts and the equations, maybe do a couple like big practice problems. I will do my best to try and pull like a practice FRQ from that unit that we're reviewing. That way we're reviewing Unit 1, I can try and find a FRQ that uses Unit 1 info. I'll do my best. That might take me a long time, but I'll try. We can keep reviewing, continually practice FRQs. Maggie, I'm glad you mentioned AP Calc. You guys did like Freaks of the Week. Is that what you called it? Because I think that's really valid of not taking the week before the test, be like, oh crap, we got to study FRQs, but do it consistently so that it becomes just kind of a habit or a strength or a skill. Any other questions? Any other advice you can give me? I want feedback. What can I do to be a good teacher, I guess? What can I do that's actually going to help you understand material, review it, or practice it? Do you guys have any ideas that you can suggest to me that I could potentially bring into the classroom to benefit you guys?
You should teach from a unicycle.
Huh?
You should ride a unicycle while you're teaching.
Oh, for goodness sake. Can you give me a logical argument that would support
Because
that request?
naturally you get caught by like.
You know, I'm going to pause the recordings. I feel like we don't.
So naturally, you get your attention gets caught by like whatever is like the most interesting, like whatever's like most moving. Notice how you don't just
Isn't the thing that's most interesting me on the unicycle, not the physics that I'm explaining?
No, but we naturally would look in your direction, look to see what you're doing, because like, all right, for example, like naturally we're not gonna go like, oh look, there's a wall. How interesting! It is a wall. Versus we see like moving, we see in our like movement.
Anyone buying this argument?
Yeah, I totally am.
Anybody?
See, I got unicycle. I put one her right.
Traitors! You're traitors to AP Physics.
Hey, I'll bring in my unicycle.